So, hello everyone. So, I don't know how to top the last performance. There was music involved, so I'm going to take you back to the awkward days of your teenage days at the schoolyard. So, I want to convince you today that teenage sex is somewhat comparable to artificial intelligence. So, if your childhood, your teenage days were anything like mine, then there were like three big topics at the schoolyard. So, who had the coolest BMX bike? Who was able to do a triple whammy backflip ollie on his skateboard, and it was about Nadia, that cutie out of the class 7B. So those are the main topics, right? And while you were still trying to figure out how to invite Nadia to a, let's say, ice cream around the corner, there was this cool dude, Justin, and he had it all. He had it all done already, so he had kissed already, he has a girlfriend for ages, so he's been to second base for a long while, right? So the sad reality is that neither Justin nor myself had a girlfriend at the time, but we were talking about it a lot, obviously. So, and this reminds us of a quote from Dan Ariely that some of you might have heard already. So I'm going to get this right. He said, big data, which is equally true for artificial intelligence, is like teenage sex. Everybody talks about it. Nobody really knows how to do it. Everybody thinks that everybody else is doing it, and everybody claims that they're doing it because of that. So what does artificial intelligence actually mean? Well, it's an ocean of a lot of different buzzwords that are floating out there, and people use quite widely without education. Now, if we look at Arthur Clarke's quote saying, any sufficiently advanced technology is indistinguishable from magic, this is what mostly happens with artificial intelligence. If we don't understand what's happening, then it's AI. It's so fast to claim that it is, where it mostly isn't. Now, what we're going to try to attempt today is find some common definitions, maybe. So let's start with machine learning. Machine learning is a whole host of different types of frameworks and methods. So if you've heard about stuff like clustering, anomaly detection, or reinforcement learning, supervised learning, those type of things, they're all part of machine learning, the school of machine learning. Now, something that you might have heard also in context with machine learning is ground truth. So algorithms are trained on something called ground truth, so that you will recognize patterns in data, and then you will say, this is trigger X, Y, Z for something to happen, whatever the purpose of your machine learning system is. Now, let's make a concrete example. So, our company, Predict.io, we do sensor fusion technology. So we have a module that can be installed on an app, and then it can predict human behavior. So we know that you're stepping into your car 10 minutes before you're stepping into your car, as an example. So how is that being done? So your phone has 13 different sensors on there. There's a gyroscope, an accelerometer, there's an air pressure measurement sensor on your phone. There's a temperature sensor on your phone, a whole host of different sensors. They produce 1 gigabyte of data per hour, up to 1 gigabyte of data per hour. So what we've done is we've collected ground truth. This is the example I want to make. So we had users out there driving their car, go about their normal lives, and then they told us what they were doing in real life. So we collected the ground truth information about what's happening. Now the algorithms, they know the patterns of the sensors because we recorded them together with the ground truth information. So now the machine learning algorithm can look for those patterns again. So it's a simple concept of pattern recognition. What you see here on the screen is an actual example of how the accelerometer data looks different when you're riding a city train versus when you're riding a bike, as an example. So where are we at? We're speaking about machine learning. We're speaking about ground truth. Those are some of the words that you might hear when you speak to the technicians. Let's make a maybe more prominent example for machine learning. So Arthur Samuelson, just after the Second World War, I believe it was in '59 actually when they came out with their first product. So IBM, he was working for them, and they launched a game of checkers. So everybody knows the game, it's a rather simple game, and they built a gaming engine that was able to learn from its mistakes. So that's one of the earliest and more prominent examples of machine learning. Now, artificial intelligence, how is it different? There is no singular definition of artificial intelligence. So again, what we're going to try to attempt today is put a little bit more meat to the bone to understand what it could be, though. So here's examples that are currently, if you read TechCrunch, VentureBeat, whatever you have it, if you read the current media, then Siri, for example, so the speech recognition assistant in the iOS phones is recognized as an example of, or successful example of artificial intelligence. You be the judge of the performance of that, but that's a different topic. So if you take RankBrain as another example, that's the current algorithm, the new algorithm of Google, how they start ranking. They use a lot of different methods, so it's a hybrid model, how it learns, and it's also considered artificial intelligence. Now, then there's Mobileye. Some of you that are in the automotive space might know that there's this Israeli company. They're very good at image recognition and a lot of other technologies that are used in self-driving cars. So most of the cars you see from OEMs out there do use Mobileye technology in the background. It's a very complex problem to solve. You have a lot of computational power that's required. You actually need to do a lot of stuff real time. So it is considered artificial intelligence currently if you read the media. And then there's DeepMind, actually another Google acquisition. And what Google did, what DeepMind does, they specialize in artificial intelligence for games. So, and here's where it might confuse you. So here's an example that's currently considered artificial intelligence, the game of Chinese checkers. So AlphaGo is an artificial intelligence that was built by DeepMind, and it plays checkers. But didn't we just say that machine learning is an example of checkers, and now checkers is also artificial intelligence? Well, I mean, that's actually part of the challenge. There is no clear definition of artificial intelligence. So really, when somebody says that, you need to start understanding what they mean with that. So currently, artificial intelligence is thrown a lot I mean, anywhere currently, everybody is doing artificial intelligence, and it's almost like the new big data. So people just, speak about it, claim it. That's why I also stole the title from Dan Ariely, so to speak. So let's try a little bit of a ballpark for you guys. So if we speak about machine learning, then you could say, if you follow the current colloquial definition that is being used in media, that machine learning is rather simplistic tasks that recognize patterns, that sort things, that sometimes rank things based on pattern recognition. So there's a lot of different frameworks and methods, like I explained earlier, for machine learning to be applied. But generally speaking, the easier it is, the more likely it is to be considered machine learning currently. Now, artificial intelligence, however, is a little bit more complex, so the things that are very hard to do currently, that have a self-learning element, that include winning strategies, but that's also a difficult definition because checkers also was about winning strategies in the end. I would say that the complexity in general is a good ballpark for you. So when somebody says AI, maybe you want to ask a little bit more what they actually mean. So, almost in closing, because I want to leave room for a couple of questions I want to make a sidestep a little bit. So I guess everybody in the room has heard about Moore's Law, more or less. So what it says is that computational powers in microprocessors is doubling very fast. So rapidly, meaning roughly a year or so, where they double. So, and this has been the fuel for a lot of the advancements we've made in many, many fields, including artificial intelligence, microprocessing, and those type of things. Now, this implies that the microprocessing has a lot of power that nearly equals our brain power, or the computational powers of our brains, in specific tasks. That's true today already. Now the question is, when does artificial intelligence actually become intelligent? So machine learning being algorithms that we build, that we train, then what mostly is considered artificial intelligence today is more or less complex machine learning in a way. Now, once we start getting into the more cognitive space, so where self-perception is something that artificial intelligence employs, where artificial intelligence is multi-purpose, where they start also learning from one thing and transfer their learnings they made in learning how to ride a bicycle onto learning how to ride a car, for example. So the basic rules of the traffic around you are the same. So transferring that, the ability to apply learnings from one field to another one, this multi-purpose type of intelligence, is what could be considered actual artificial intelligence in the end. So here's another piece of information I stole. So there's a guy called Sam Harris. He has an awesome TED Talk. I strongly recommended watching it. And he actually makes up a funny thought. So if we were to say that, that aliens would land on Earth, so let's say in Berlin-Hohenschönhausen. So if aliens would land in Hohenschönhausen, what would happen? If we knew that would happen in 40 years from now, I don't know, we would start either weaponizing ourselves, or maybe we would start, training a dance routine, or learning a new language, or whatever we would do. But I think we would get prepared for aliens to land in Hohenschönhausen. Now, we know for a fact that this singularity, and that's another disputable term as such, that this singularity where we have multi-purpose type of intelligence that supersedes human intelligence is going to happen soon. There's no significant advances in technology required for that to happen. So we can forecast it to some extent, we're going to speak about that in a second, but we know that it is going to happen. Why are we not getting prepared for it? It's a good question. I don't know what to do, the dance routine or not, but we should start speaking about it a little bit more. So maybe speaking about singularity and trying to define that term a slight little bit. So there's Werner Winch, and he spoke about the singularity to happen in the next 30 years, and that was 93. So in 2023, according to him, we would have that intelligence superseding human intelligence. If you follow somebody like Ray Kurzweil, then you rather look at a time frame of 2045. So you have Google that founded a university in the Valley that's called the Singularity University, and actually the purpose of that university is to prepare mankind for the advent of superhuman intelligence to arrive at this planet, but based on an artificial intelligence. So it is happening, and we're not getting prepared. So it's a weird concept to me. So that's almost the closing. So what's the point? The point being is, don't buy if somebody says they're doing AI. I mean, it's fine if they use the term. I do it at times. If I speak to marketing people, if I speak to technicians, I don't. So the question really is, what do people mean when they say machine learning, when they say artificial intelligence? So maybe just getting that slight bit of education, one more granular level, understanding which different methods you have in machine learning that make sense for specific areas and don't make sense for other areas. And if somebody says they have an AI, maybe be a little bit alert, because it is a buzzword as such. And it's fine if you understand what they mean by it, but there's no magic behind it, really. So there's contact details. If you have questions, either directly after this, you can also shoot them over. I'm super happy to take questions now, if there are any in the room, actually. Any questions here?
Come on, guys.
I confused everybody,
I'll
I guess.
ask a question. Come on, Silvan. How do you define the singularity?
So I think the multi-purpose piece is most convincing to me. So if you have something that can self-perceive itself's entity, so to speak, and can use the intelligence in multiple fields, that's when we start speaking about the, nearing the singularity. It's an equal buzzword as the others, I would say.
Let me just slide you over so you don't get run over by my stage
that
hands.
makes sense.
Here, come over here. Who has the question? We've got time for one question from the audience. There we go, you, sir. Will you make your way to the microphone, or will you shout? Oh, you're losing your iPhone there.
You're losing your phone.
Can we get this mic turned on? This
Yes,
on the right.
IBM, I learned, is building ships which are able to replace 20% of human brain. If I do a simple calculation, let's say a couple of 5 years, then they are able to have a complete human brain. What kind of intelligence is then coming out of this? Is this artificial intelligence or human intelligence?
So maybe let me sidestep first a little bit. There's a lot of processing or a lot of stuff happening in the processor world. So to make an example, Apple has partnered with NXP, the chipset provider, and they have a co-processor that's on your iPhones. So there's a hardware chip on your iPhones that does nothing else but interpret the sensor data. They put hardware into your phone that does it, right? So then you have a chipset or a concept that's being built, and first applications on military, unfortunately. It's called Iris, and Iris is a specialized chip that is specializing in machine learning tasks, does it with very low power consumption, and I believe those type of things will actually help us get there. So the more you can put the intelligence into where it needs to be, so close to the sensors, close to where the robot is interacting with the world, the closer we get to autonomous systems. I cannot really answer if what we have in the end is human intelligence or not, because, I mean, what's human after all? What do we define as human? What do we define as self-perception? So, I mean, there's a lot of ethical questions, obviously, around this, and they're way too big for my brain at the moment, right?
Well, we're going to bring up some other brains in a little bit. Silvan will be taking questions also at the meeting point. This is out the door and to the right, so if you have a question and you didn't get a chance to ask it, Silvan will be generously answering questions at the meeting point. Thank you so much for your presentation.